Isn't it just mind-blowing what these language models can do now? I mean, generating text that sounds human, answering really complex questions, even spitting out working code.
It really is something else.
But here's the thing I've been realizing. It's like, um, it's a super-powered tool, right? You only get out what you put in.
Exactly.
And with these LLMs, that input, that prompt, it feels like everything. Anyone can type a question, sure, but really unlocking their potential. That's prompt engineering, isn't it?
Absolutely. Yeah, think about giving instructions to someone. If you're vague, you'll probably get a vague result back.
Right.
Prompt engineering is essentially about crafting really clear, high-quality instructions for these AI models. It's not just about making the prompt longer either.
Okay.
It's more about experimenting, different ways of phrasing things, structuring your request, even the style you use, trying to find that sweet spot that gets you the most, well, accurate and relevant output.
Okay, so let's unpack that bit accurate and relevant output. What kinds of things can we actually do with, like, skillfully engineered prompts? It feels like it goes way beyond just asking Google a better question.
Oh, you're spot on. Yeah, the range of applications is actually quite astonishing when you think about it.
Like what?
Well, imagine taking a huge document, right, and instantly getting a concise summary of the key points.
Okay, yeah, that's useful.
Or extracting very specific data points from, like, a wall of text without having to read every single word. Prompt engineering makes that possible. You can ask really nuanced questions and get insightful answers. It's also incredibly useful for classifying text. Think about automatically sorting customer feedback, positive, negative, that kind of thing.
Oh, okay.
And it's not just limited to human languages. You can even translate code between different programming languages or generate new code just from a description of what you need.
Wow. That's a seriously versatile skill set we're talking about then. So for someone listening who's thinking, okay, I want to get better at this, what's the absolute first thing they should keep in mind?
The very first step, maybe even before you write a single prompt, is thinking about which large language model you're going to use.
Ah, okay. The model itself.
Yeah. Different models, whether it's, Gemini, GPT, Claude, Gemma, Llama, they're all trained on different data and their own particular strengths.
Right.
So what works incredibly well on one might need a little finesse, a little tweaking to get the same result on another. It's like choosing the right tool for a specific job.
Yeah.
Optimization for your chosen model is really key.
That makes total sense. Like you wouldn't try to cut down a tree with a butter knife.
Right. Exactly.
So, okay, we've picked our LLM. Now we write the perfect prompt. Or is it that simple? I remember reading that the LLM settings themselves also have a huge impact.
You're right, not so fast. The prompt is crucial, no doubt about it, but the LLM's output configuration settings, they're like the fine-tuning controls.
Yeah.
They can significantly influence the kind of results you see. Think of it like adjusting the knobs on a soundboard to get the perfect audio mix.
Okay, I like that analogy. So what are the most important knobs we need to understand on this LLM soundboard?
Well, one really important setting is the output length, usually measured in something called tokens.
Tokens, right. Roughly words or parts of words.
Yeah, pretty much. LLMs process and generate text token by token. And this setting tells the model the maximum number of tokens it can output.
Okay.
Now, you might assume that setting a shorter token limit will automatically give you a more concise answer.
Yeah, that seems logical.
But it doesn't always work that way.
Yeah.
It just tells the LLM when to stop generating, even if it's like in the middle of a sentence or a thought.
Okay, so it just taps off.
Right. And this is something particularly important to keep in mind if you're using more advanced techniques like React, that one can sometimes keep generating thoughts and actions even after it's given the core answer.
Right.
Also, just remember that longer outputs need more computation, which can mean slower responses and potentially higher costs too.
So just hitting a shorten button isn't the magic bullet for conciseness. Got it. What other controls do we have over the output? Feels like there should be more.
Oh yeah. We also have what are called sampling controls. These determine how the LLM chooses the next token in its response.
Okay, how it picks the next word.
Essentially, yeah. Instead of just picking the single most likely token every single time, LLMs actually predict probabilities for a whole range of potential next tokens. Temperature, top K, and top P are the main settings that control how these probabilities are used to select the final output. They control the randomness, basically.
Temperature, and that sounds interesting. What does that actually do?
So temperature controls the randomness in the LLM's output. A lower temperature, closer to 0, makes the model more deterministic.
Deterministic, meaning predictable.
Exactly. It'll consistently pick the tokens it thinks are most likely, which is fantastic when you need factual, very focused, or, yeah, predictable answers. In fact, a temperature of 0 is often called greedy decoding
Greedy decoding. Why greedy?
because the model always greedily grabs the single most probable next step, no exploring.
Okay.
On the other hand, a hybrid temperature injects more randomness, leads to more diverse and sometimes more creative or unexpected results.
Ah, okay.
Think of it like this. Low temperature makes the LLM stick to the safest, most obvious path. High temperature encourages it to explore more surprising, maybe novel routes.
Right.
In the context of something like Gemini, its temperature control is similar to the softmax function you see in machine learning. Lower setting really emphasizes the high probability options. Higher setting makes a wider range of less probable options more acceptable.
So low for when you need the straight facts, high for when you want a bit of creative flair. That makes intuitive sense. What about top K and top P? They sound like they also help guide the output.
They do, yeah. Both top K and top P. Top P is sometimes called nucleus sampling. They help narrow down the LLM's choices to only the most probable tokens.
How does top K work?
Top K sampling works by selecting from only the top K most likely tokens.
Oh.
If you set K high, the model has more options, can lead to more creative, varied output.
Okay.
But if you set K low, it becomes more restrictive, tends to stick to more common factual phrases. And just like with temperature, a top K of 1 is also greedy decoding. Only the single most likely token is even considered.
And how is top P different then? K is a number of tokens. What's P?
So top P sampling works a bit differently. Instead of a fixed number K, it looks at the cumulative probability.
Cumulative. Okay.
It selects from the smallest set of tokens whose total probability adds up to exceed a certain value, P. And P is a number between 0 and 1.
Ah, right.
Again, P equals 0 is greedy decoding. P equals 1 means all tokens in the entire vocabulary are potentially in the running. Think of it like having a probability budget, P, and you pick the most likely tokens until you spend that budget.
So K is a hard limit on the number of options. P is a limit based on the total probability. That's a really helpful distinction. Now, is there some kind of magic combination, like the perfect settings for everything?
If only.
Mm-hmm.
Sadly, no. No universal magic formula. The best approach is always to experiment.
Right. Trial and error.
Exactly. See which combination of temperature, top K, top P, gives you the kind of results you're aiming for. For your specific task with the particular LLM you're using. And it's really important to remember they interact,
Interact. How so?
Tweaking one can influence how the others behave.
Yeah.
If you change the temperature, it might affect how many tokens fall within your top E threshold, for example.
Interesting. Okay, so experimentation is key. But do you have any general starting points, like if I want creative versus factual?
We do have some rough guidelines. If you're looking for results that are pretty coherent but still have a touch of creativity, maybe start with temp around 0.2, top P about 0.95, and top K maybe 30.
Okay, balanced.
If you want something particularly creative, maybe a bit more unexpected, you could crank the temperature up, maybe 0.9, top P closer to 0.99, top K around 40.
Higher settings for creativity. Makes sense.
And if you need less creativity, more focused, almost factual output, try a lower temp, like 0.1, top P maybe 0.9, and top K around 20.
Lower settings.
And for tasks where there's usually only one right answer, like solving a math problem, starting with temp is often the best bet. Greedy decoding.
Those are some really helpful starting points. Thanks. One last thing on this. I seem to recall reading something about these settings sometimes causing the LLM to get stuck, like in a loop.
Yes. That's the dreaded repetition loop bug.
Okay.
It's a known issue. The LLM gets stuck in a cycle, just repeating the same word or phrase or even a whole sentence over and over.
Why does that happen?
It can actually happen at both very low and very high temperatures, but for different reasons. Low temps, the model can become too predictable, just keeps repeating the highest probability sequence.
Right, gets stuck on the best option.
Yeah. And at high temps, the increased randomness can, just by chance, lead it back to a previous state, and boom, you're in a loop. Finding that sweet spot with your settings is often crucial to avoid it.
That's a really useful heads up. All right, so we've got a handle on configuring the output. Now let's really get into the heart of it. The prompt engineering techniques themselves. Where should we begin?
Let's start with the most basic, but still surprisingly versatile one, zero-shot prompting.
Zero shot, okay.
The core idea here is incredibly simple. You just give the LLM a description of the task you want it to do, maybe some starting text like a question or an instruction, but you don't give it any examples of the output you want.
Aha, hence zero shot. 0 examples.
Exactly. You're giving it 0 examples to learn from in the prompt itself.
So it's like just saying, hey, could you do this? Without showing it what this looks like first. Can you give us a clear illustration?
Absolutely. Let's imagine you want to classify movie reviews. Positive, negative, neutral.
Okay, standard sentiment analysis.
Right. A 0-shot prompt might look something like, classify the following movie review as positive, neutral, or negative. Movie review. The acting was superb, and the plot kept me on the edge of my seat. Highly recommended. Sentiment.
And then you just let the model fill in the blank.
Yep. And in this case, the expected output would just be positive.
That seems really direct. Just tell it what to do, give it the input. I noticed in our resources, though, it mentioned documenting your prompts, maybe using a table. Why is that so important?
Yeah, that's crucial. Because in the real world, prompt engineering is rarely a one-shot deal.
Yeah.
You'll likely go through multiple tries, right?
Right. Tweaking and refining.
Exactly. Documenting each attempt in a structured way, a table is great for. This helps you keep a clear record. What you tried, what worked, what didn't, the specific settings you used. It becomes incredibly valuable when you need to revisit your work later, or test prompts on different models, or just figure out why something isn't working as expected.
That makes perfect sense. Trial and error without a logbook is just, well, error repeated. So what happens when 0-shot isn't quite cutting it? When it's not getting the results we need?
That's where one-shot and few-shot prompting come in.
Okay, 1-shot, few-shot.
The key difference here is you start providing the LLM with examples. Examples of the task and the kind of output you want.
Ah, okay, so you show it what to do.
Precisely. A one-shot prompt includes just a single example. A few-shot prompt provides multiple examples, usually like 3 to 5.
3 to 5 examples. Is that a hard rule?
It's a common guideline, but the best number really depends. How complex is the task? How good and varied are your examples? What's the LLM capable of?
Right.
And you also have to watch the input length limits. Each example adds to the prompt length.
Can you walk us through a practical example? Like, how would few-shot work?
Sure. Let's say you want to parse customer pizza orders into a structured JSON format.
Okay, extract structured data.
Right. A few-shot prompt might look something like this.
Yeah.
Parse the following customer pizza orders into valid JSON format. Then you give examples. Example, customer order. I'd like a medium pizza with pepperoni and extra cheese. JSON response. Medium, toppings. Pepperoni, extra cheese.
Okay, one example down.
Example, customer order. Can I get a large vegetarian pizza with mushrooms and olives? JSON response. Large toppings, mushroom style, vegetarian.
Got it. Shows different fields.
Now parse this order. Customer order. I want a small pizza with just tomato sauce and basil. JSON response. And then the model should output small toppings, tomato sauce, basil.
Ah, I see how that works.
Yeah.
The examples clearly demonstrate the input to output transformation you want. What makes for a really good example in these cases?
Quality is absolutely crucial. The examples need to be directly relevant, obviously.
Right.
They should also be diverse enough to cover different scenarios, different variations in the input.
Makes sense.
And of course, they have to be accurate and high quality, like well written, no mistakes. Even a small error in an example can confuse the model.
Yeah, garbage in, garbage out, even for examples.
Exactly. And if you need the model to be robust, handle weird inputs. Maybe include some edge cases in your examples too.
That's really insightful. Okay, so we've got 0-shot, 1-shot, few-shot, based on examples. What are some other key prompting techniques we should be aware of?
Next up, we have a set of techniques that focus more on guiding the generation process from different angles. System prompting, contextual prompting, and role prompting.
System contextual role.
System prompting is about setting the overall context and purpose, like telling the model it's a translator or a summarizer.
High-level instructions.
Yeah. Contextual prompting is giving specific details or background info relevant to the current task, helping it understand nuances.
Like feeding it relevant facts first.
Right. And role prompting is where you assign a specific character or persona to the LLM. Encourages it to generate responses consistent with that role's knowledge, behavior, style.
Giving it a personality, almost.
Pretty much.
It sounds like these could sometimes overlap a bit, couldn't they? Like a system prompt that also sets a role.
Exactly. Yeah. While they each have a primary focus, you can definitely combine them effectively.
How so?
For instance, a system prompt might instruct the LLM to act as a helpful and concise technical support agent. That's the role.
Okay.
And then the next prompt might provide the specific technical issue a customer is facing. That's the context.
Ah, I see. Using them together. Let's dive a little deeper into each one. How can we best use system prompts?
System prompts are fantastic for establishing those high-level guidelines. For example, you could use one to tell the LLM to always return its answer in a specific format, like a bulleted list, or as we mentioned, JSON.
Right, enforcing structure.
Yeah, super useful if you need structured data for like plugging into another system.
Yeah.
Specifying JSON in a system prompt can also help the model be more organized and maybe even reduce the chance of it making stuff up hallucinating because it has to stick to that defined format.
Interesting. Any other uses?
Yeah, you can use them for broader control too, like instructing the model to always be respectful, avoid generating harmful content, setting safety guardrails.
So it's like setting the rules of engagement before the real conversation starts. Okay. What about role prompting? How can we effectively leverage that?
Role prompting is all about giving the LLM that specific hat to wear, like you said.
Yeah.
By assigning a role, maybe a seasoned travel writer, a knowledgeable historian, a witty comedian, you encourage much more tailored responses aligned with that role's expertise and style.
Can you give an example?
Sure. If you prompt it to act as a travel guide, specializing in Amsterdam, and ask for recommendations, you'll likely get suggestions about museums, canals, maybe local cafes.
Makes sense.
But if you then change the role to, say, a food critic specializing in Amsterdam and ask the same initial question, you'd expect very different recommendations, restaurants, culinary experiences.
That's a really clever way to influence the output just by changing the persona. Are there different styles or tones we can apply within role prompting?
Absolutely. You can specify not just the role, but also a particular style or tone for that role.
Like what?
Oh, anything really. Confrontational, descriptive, direct, formal, humorous, influential, informal, inspirational, persuasive, you name it.
Wow.
So if you wanted that travel guide from Manhattan to be a bit more entertaining, you could ask it to provide suggestions in a humorous style. You'd likely get much more lighthearted, amusing recommendations.
That sounds like it could add a lot of personality. Okay, now, contextual prompting seems fairly straightforward given background info, but how do we use it most effectively?
Contextual prompting is all about providing the LLM with the specific details it needs to really understand the current task, give it relevant context, help it generate more accurate, nuanced, tailored responses.
So just feeding it the right facts.
Pretty much. Like if you're asking for blog article topics, just asking for blog ideas is vague. But if you provide context like, the blog is for enthusiasts of retro 1980s arcade games.
Then you'll get much more relevant suggestions.
Exactly. Pac-Man, Donkey Kong, that kind of thing, not just generic stuff.
Okay, we're building up a really solid toolkit here. Zero shot, few shot, system, context, role. What's next on our list to explore?
We should definitely talk about step-back prompting. This is a really interesting one.
Step-back prompting. Okay.
It can often lead to improved performance, especially on complex reasoning tasks. The idea is you first prompt the LLM with a more general related question before you ask the specific question you actually care about.
Oh, why would you do that?
Because the answer to that more general step-back question then helps inform the LLM's response to your main prompt. It sort of activates relevant background knowledge.
So it's like taking a mental step back to consider the broader picture or the basic principles before diving into the specific.
Precisely. That initial step back lets the LLM access relevant knowledge and reasoning processes it might not grab if you just hit it with the specific complex task cold. It can encourage more critical thinking, sometimes lead to more accurate, insightful answers. Might even help mitigate some biases by focusing on general principles first.
Can you give us a practical example? How might this be used?
Okay, let's say you want the LLM to come up with a cool storyline for a new level in a first-person shooter game.
Right.
A traditional prompt might be, write a one-paragraph storyline for a new FPS level. Might work, but could be pretty generic.
Yeah, could be anything.
Now, using step-back prompting, you might first ask, what are some common and effective settings or themes used in popular FPS games?
Okay, priming it with common trope.
Exactly. The LLM might list things like abandoned military base, alien spaceship, underwater research facility.
Got it.
Then for your final prompt, you incorporate one of those as context. Think context. An underwater research facility is a common setting. Based on this, write a one-paragraph storyline for a new FPS level set in an underwater research facility.
I see. By providing that broader context first, you're much more likely to get a focused, interesting storyline related to that specific setting.
Exactly. You're priming it with relevant foundational knowledge.
That's a really clever approach. Okay, what's another powerful technique we should learn about?
Let's delve into chain of thought, often just called QT prompting.
To thought. CoT,
Right?
okay.
This technique specifically aims to improve the reasoning capabilities of LLMs, especially for more complex problems. The core idea is to explicitly ask the LLM to generate the intermediate reasoning steps it takes to get to the final answer.
So you're not just asking for the solution, you're asking it to show its work, basically.
Exactly that. And the fascinating thing is, often, by forcing the LLM to articulate its reasoning, you actually get a more accurate final answer.
Really? Just making it explain
It
helps.
often does.
So,
You can even combine CoT with few-shot prompting by giving examples that include the step-by-step reasoning.
okay. Showing it how to show its work.
Right. One big advantage of CoT is it's pretty easy to implement. Works well with many off-the-shelf LLMs, no fine-tuning needed usually.
Nice.
Plus, it gives you interpretability, right? You can see the steps the model took. Invaluable for understanding why it got an answer, or debugging if it messed up. Seems to make prompts more robust across model versions, too.
That sounds incredibly useful, especially for trickier problems. Are there any downsides?
The main one is token usage. Because the LLM is generating all those reasoning steps plus the final answer, the response is longer.
Right. More tokens means more cost, potentially slower.
Exactly. So it's a trade-off.
Seems like a reasonable one for better accuracy and insight, though. Can you give a clear example of CoQ in action?
Let's take a classic word problem. When I was 3 years old, my sister was twice my age. Now I am 30 years old. How old is my sister?
Okay. A bit tricky if you just jump to conclusions.
Right. If you ask directly, an LLM might incorrectly say 60, just doubling your current age.
Yeah, I could see that happening.
But if you use a zero-shot CoT prompt, maybe just by adding, let's think step by step at the end.
Just add that phrase.
Often, yeah. The LLM is then encouraged to generate the reasoning. First, it calculates the age difference. She was 6 when you were 3, so a 3-year difference. Then it applies that difference to your current age. 30 plus 3 equals 33, arriving at the correct answer.
Wow, just adding let's think step by step makes such a huge difference in the reasoning quality. You mentioned single shot and few shot CoT too. How did those work?
It's just like regular one-shot and few-shot. But in your examples, you don't just give the question and final answer.
You include the steps.
Exactly. You include the step-by-step reasoning that leads from the question to the answer. So for a few-shot CoT, you'd provide several examples. Question, let's think step by step. Detailed reasoning, final answer. Gives even more explicit guidance.
Gotcha. So CoTT is great for tasks that need breaking down into logical steps. What's another technique in our arsenal, maybe building on this?
Yeah, building on CoT, we have a technique called self-consistency.
Self-consistency.
Okay. So standard code often relies on, like, greedy decoding, picking the most likely next step. Self-consistency takes a different path.
How so?
It involves generating multiple different reasoning paths for the exact same prompt. You do this by using sampling with a higher temperature, which introduces more variability.
Okay, so run the COTO multiple times with more randomness.
Right. Then you look at all the different answers these diverse reasoning paths lead to, and you select the most consistent answer across all those paths, usually using majority voting.
Like asking several different experts who are all the same LLM or differently, and taking the most common answer.
That's a great way to put it.
What are the benefits and drawbacks there?
Main benefit: can significantly improve accuracy and robustness, especially for complex tasks where there might be multiple ways to get the solution. Gives you a sort of pseudo-confidence score in the most frequent answer.
And the downside? I'm guessing cost again.
You guessed it. Big drawback is the increased computational cost. You're running the same prompt multiple times, right? Uses considerably more resources, takes more time.
Makes sense. Can you give an example where self-consistency would be particularly valuable?
Imagine classifying customer emails. Again, positive, negative, neutral. Some emails might have subtle sarcasm, tricky phrasing.
Right, ambiguous stuff.
Using self-consistency with a CoT prompt, you could run the classification multiple times with slightly different settings. You might get slightly different reasoning, maybe even different sentiment classifications each run.
Okay.
By tallying up the results and choosing the sentiment that popped up most frequently, you get a more reliable, confident classification.
That's a really interesting way to handle ambiguity and get a more robust result. Okay, what about tree of thoughts? Sounds like yet another evolution of the CoT idea.
Exactly. Tree of thoughts, or TOT, is like a further generalization of CoT.
How does it generalize?
Instead of just exploring a single linear chain of reasoning steps, TOT lets the LLM explore multiple different reasoning paths in parallel. It maintains a sort of tree structure of thoughts.
A tree of thoughts, literally.
Yeah, where each thought is an intermediate step. This approach is particularly good for really complex tasks that might require exploring various options, evaluating them,
Yeah.
maybe even backtracking if a path looks unpromising.
So it's like building out a whole decision tree of potential reasoning within the LLM itself.
Precisely. The model can branch out, explore different possibilities, maybe revisit earlier steps, combine insights from different branches,
Yeah.
all to find a solution. Allows for a much more flexible, exploratory problem-solving process.
That sounds incredibly powerful for tackling truly intricate problems.
Mhm.
Wow. Okay, what's another advanced prompting technique we should cover?
Let's talk about REACT. Stands for Reason and Act.
React. Okay.
This is a bit of a paradigm shift. It goes beyond just generating text. REACT lets LLMs solve complex tasks by combining that natural language reasoning with the ability to interact with external tools.
External tools, like what?
Like search engines, code interpreters, API. This allows the LLM to not only think through a problem, but also to take actions in the real world, or a simulated one, retrieve information, essentially learn as it goes. It's a big step towards building more autonomous AI agents.
So it's not just thinking and writing, it's also doing things and observing the results. That sounds much more like how humans actually solve problems.
Exact. REACT tries to mimic that process. Reason about what you need, take action to get info or change something, observe the result, update your reasoning, repeat.
The thought-action-observation loop.
You got it.
Yeah.
The LLM first reasons, decides on an action, maybe uses a search engine, then it observes the result. What did the search return? Based on that, it updates its reasoning, decides the next step, keeps going until it thinks it's done.
That's absolutely fascinating. Giving the LLM agency to investigate and learn actively, can you give a concrete example? How might a React agent work?
Okay, remember that question. How many children does a famous dad in Metallica have?
Yeah.
A React agent might first reason. I need to know who's in Metallica. Action. Search Metallica band members. Observation. Gets list of names, Hetfield, Ulrich, etc. Next thought. Okay, need to find kids for each member. Action. Search James Hetfield children. Observation. Gets a number. Action. Search Lars Ulrich children. Observation. Gets a number.
And so on for each member it found.
Right. After observing all those results, it updates its knowledge, synthesizes the info, and provides the final answer.
So it breaks down a complex, multi-step question into manageable subtasks, using tools to gather info along the way. That's a huge leap. Now, we've talked about all these really useful ways to manually craft prompts. What about automating this? I recall seeing something about automatic prompt engineering.
Yes, automatic prompt engineering, or APE, really interesting evolving field. The goal is to use LLMs themselves to help us generate better prompts.
That sounds very meta, using AI to improve how we talk to AI.
Pretty much. The basic idea is prompt one LLM to generate multiple different variations of a prompt for a specific task you have. Then you automatically evaluate how well those generated prompts perform, maybe using some automated metric, see which ones get the best results.
And then
You can even take the best ones, tweak them further, repeat the evaluation, iterate to continuously refine and improve your prompts.
that sounds very efficient. Can you give a practical scenario where APE might be useful?
Let's say you have an e-commerce site selling band t-shirts. You want a chatbot to understand all the ways customers might order.
Right, people phrase things differently.
Exactly. Instead of manually trying to list every variation of, I want a small Metallica t-shirt, use APE.
Yeah.
Give a basic prompt to another LLM. Generate many different ways a customer might request this item.
Okay.
It might spit out, can I order a small Metallica tee? Looking for a Metallica shirt and small Metallica t-shirt, please, and tons more.
And then you test those.
Yeah, evaluate them, maybe test them on your chatbot, or use metrics for intent capture.
Right.
Select the most effective ones to use for training or for your actual system prompts.
That sounds like a really efficient way to generate diverse training data or just discover better ways to phrase your own prompts. Okay, we've covered a lot on general language. What about using prompts for something like writing code?
Ah, yes, code prompting. Increasingly powerful, very common use case now. Models like Gemini are strong at understanding and generating code from text prompts.
Like, it can actually help developers write functional code.
Absolutely. You give Gemini a prompt, clearly describing the functionality, specify the language, and it can often generate a working code snippet.
Example.
You could ask it, write a bash script that takes a directory name as an argument and renames all files inside by adding the prefix old to each file name.
That sounds incredibly useful for automating tedious stuff, but can we really trust the code it generates? Is it always correct? Secure?
That's a really, really critical point. Yes, they're getting better, but LLMs don't truly reason like human programmers. They're sophisticated pattern matchers trained on vast amounts of code.
Okay. So pattern matching, not understanding.
Right. Therefore, it is absolutely essential that you carefully read, review, and thoroughly test any code generated by an LLM before you use it in a real project or rely on it.
So test that bash script first.
Definitely. Test it on a sample directory with non-critical files. Make sure it does exactly what you want, doesn't delete anything important. Safety first with code.
Got it. It's an aid, not a replacement for human review and testing. What else can LLMs help with in coding?
They can also be incredibly helpful for understanding existing code.
How?
You can feed an LLM a code snippet, any language pretty much, and ask it to explain what it does, its purpose, how a specific function works.
Oh, wow.
Invaluable when you're dealing with unfamiliar code bases, legacy systems, or just trying to grasp complex logic someone else wrote.
That would be like having a super patient colleague explaining code on demand, a real time saver. What about translating code between languages? Can they do that?
Yes, they're getting quite capable at assisting with code translation too. Give it Python, ask for JavaScript, for instance.
Cool. Same caveats apply, I assume.
Absolutely. Just like with generation, you must carefully review and test the translated code. Ensure it functions correctly, achieves the same outcome. Be aware of idiomatic differences or best practices in the target language the LLM might miss. Human oversight is still essential.
So, great starting point for translation, but needs human refinement. What about debugging and reviewing code? Can they help there too?
Definitely. Feed it code that's erroring out, along with the error message or traceback. Ask it to help find the cause and suggest a fix.
And it can do that.
Often, yeah. They can quickly spot syntax errors, logical flaws, common mistakes. Plus, you can ask it to review your code for improvements, efficiency suggestions, better data structures, even potential security vulnerabilities.
Really? Security too?
It can sometimes spot common patterns associated with vulnerabilities, yeah. In one of our examples, given broken Python and the error, the LM not only found the undefined function, but also suggested other improvements, making it more robust, readable.
That's incredibly helpful. An AI assistant for debugging and code review sounds like a massive productivity boost for developers. Could save hours of frustration. Okay, we've talked a lot about text and code. What about other kinds of input? I remember seeing a brief mention of multimodal prompting.
Yes, exactly. While co-prompting is mainly text-based right now, multimodal prompting is the exciting frontier. It means using multiple input formats, text, images, audio, video, maybe other data, to guide the LLM.
So feeding it an image and text.
Yeah, potentially. The specific capabilities really depend on the LLM. Not all models can handle multiple modalities, and what they can do with them is still evolving fast.
Okay, something to watch for the future. This gives us a really comprehensive overview of techniques. Now, to really level up, what are some absolute best practices we should always keep in mind when crafting prompts?
Right, best practices, super important. First and foremost, always remember, finding the really effective prompt is very often an iterative process.
Don't expect to nail it first try.
Exactly. Tools like the Language Studio in Vertex AI are invaluable here. Let you easily experiment with different prompts, different model settings.
So it's all about that cycle. Try, evaluate, refine. What else is crucial?
Examples. As we discussed, providing clear, relevant examples, one shot or a few shot, is incredibly powerful. They're essential teaching tools for the model. Show it the format, style, content you want.
Okay. What about the prompt itself? Should we aim for super complex, detailed prompts, or is simplicity better?
Generally, design with simplicity in mind. Keep prompts concise, clear, easy to understand, for you and for the LLM.
If I can't understand it, the model probably can't either.
Pretty much. Avoid overly complex language, jargon, unnecessary info. Use strong action verbs. Clearly state what you want. Instead of tell me about good places to eat in Rome, maybe list 3 highly rated Rome restaurants describing cuisine and average price.
Be direct. Okay. What about being really specific about the output we want?
Absolutely. Don't leave things to chance. Be as specific as possible about the output format, style, content. Generic instructions might not give enough direction. Use system or contextual prompts to provide those specifics. Helps focus the model, improves accuracy.
Well, instead of write about consoles.
Right. Better is, write a blog post titled Evolution of Gaming. Target audience, casual gamers 25-45. Discuss key innovations and cultural impact of at least 4 major consoles, including release year. Much clearer.
Gotcha. Now, I've heard different things about telling the LLM what to do versus what not to do. Instructions versus constraints. What's the recommended approach?
Yeah, good question. Research and practice suggest Focusing on positive instructions, telling the model what you want, is often more effective than relying heavily on negative constraints telling it what not to do.
Why is that?
Instructions directly communicate the goal. Constraints can sometimes leave the model unsure what is allowed or desired. So, prioritize clear, positive instructions. Use constraints mainly for safety, enforcing strict formats, or clarifying absolute no-goes.
So instead of don't mention specific games.
Better to focus on what you do want. Write about console history and impact, focusing on technological advancements and cultural significance. Guide it towards the positive goal.
That's a helpful distinction. Should we always let the LLM decide the length or control it?
Definitely control the max length. Either set a token limit in the configuration like we discussed,
Right, a hard limit.
or explicitly request a length or format in the prompt itself, like summarize this in no more than 150 words, or explain quantum physics in a tweet-length message.
Okay. What about reusing effective prompts? Can we make that easier?
Absolutely. This is where using variables or placeholders in your prompts is super useful.
Like a template.
Exactly.
Yeah.
Instead of hard-coding specifics, use variables you can change each time. Makes prompts much more reusable, flexible, dynamic, especially good for integrating into larger apps.
Nice. What about just trying different ways of phrasing the same basic request? Is that worth doing?
Definitely. Experiment with input formats, writing styles. Try phrasing as a question, a statement, an instruction. Different models, different configs can respond differently to subtle variations. Always worth exploring.
So asking about the Sega Dreamcast as a question versus a statement might yield different results.
It might. Worth
Okay.
trying. What were the Dreamcast's key features? Versus describe the Dreamcast and its significance. Versus list the 3 most innovative Dreamcast features. See what works best.
Okay. For those classification tasks, using Fuchsia examples, does the order of examples matter? Like positive, negative, positive?
Yes, good point. For classification, it's generally good practice to mix up the different response classes in your examples.
Why?
While order shouldn't theoretically matter much to a good model, mixing helps prevent accidental overfitting to the presentation order. Leads to more robust performance on new data. As a starting point, maybe try around 6 diverse few-shot examples when testing.
Okay, mix it up. Now, these LLMs keep getting updated, right? Do we need to adapt our prompts over time?
Absolutely crucial. Stay informed about updates, new features, changes. Updates might introduce new capabilities or change how prompts are interpreted. You might need to adjust prompts to leverage new features or just maintain performance.
So prompt engineering isn't a one-time thing.
Definitely not. This is where good documentation is gold. And tools like Vertex AI Studio help store, test, and track versions.
We talked earlier about getting structured output like JSON. Any best practices there?
Yeah, for non-creative tasks, extraction, selection, parsing, definitely experiment with structured formats like JSON or XML.
Why JSON specifically?
It offers lots of advantages. Consistent format focuses on data, can reduce hallucinations, represents relationships, includes data types, easily sortable and processable by other systems.
Okay. Any downsides?
It could be verbose sometimes, might hit token limits. If that happens, tools like the JSON repair library can be lifesavers for fixing incomplete or slightly broken JSON.
JSON repair. Good tip. What about providing structured data to the LLM? How to do that well?
Right, input structure. Using JSON schemas is incredibly beneficial here.
Schemas, like a blueprint for the JSON.
Exactly. Defines the expected structure, data types, gives the LLM a clear understanding of the input data, helps it focus, reduces misinterpretation, establishes relationships, can even make the LLM sort of time-aware in advanced uses.
That sounds really powerful for providing rich, well-defined context. Any other collaborative tips? Is prompt engineering better as a team sport?
It definitely can be. If you're facing a tough challenge or optimizing for something critical, collaborate. Different people bring different perspectives, ideas, maybe different LLM understandings.
Fresh eyes, fresh brains.
Exactly. Sharing approaches, discussing challenges, brainstorming together often leads to much more effective, robust prompts than working alone. Plus, it builds team expertise.
Makes perfect sense. What about specific best practices for chain of thought? Anything special to keep in mind?
Yeah, for Casimo, first make sure the final answer is clearly stated, usually after the reasoning steps.
Okay, reasoning first, then answer.
Second, if you're using self-consistency, you need to be able to easily extract just the final answer programmatically, separate from the reasoning.
Right, for the voting.
And finally, since Coty often aims for a single logical answer, usually best to set temperature to 0 or very low. Encourage deterministic reasoning.
Got it. And given how iterative this all is, what's the absolute best way to manage all these attempts and results? You mentioned documentation.
Meticulous documentation is absolutely critical. Cannot stress that enough.
What should it include?
Keep detailed records of every prompt attempt. Use a template, prompt name version, goal, LLM config settings, the full prompt text, the output you got. Note if it was satisfactory. Add observations.
Be systematic.
Yes. Use tools like Vertex AI Studio to save prompts, link to them in your docs. If you're doing R, document the RAG system config too that influences prompts. Once you find a good prompt, save it in your code base. Add automated tests, evaluation.
Treat prompts like code, almost.
That's a good way to think about it.
That's a really comprehensive set of best practices. It truly underscores that prompt engineering is a valuable skill. Requires creativity and a systematic, almost scientific approach.
Exactly. It's that ongoing cycle.
Mm.
Carefully craft, rigorously test, thoroughly analyze, continually refine based on what you learn. Keep experimenting, keep documenting, and you'll definitely see your ability to get powerful results from these models keep growing.
Well, we've certainly taken a deep dive into the fascinating world of prompt engineering today. Wow. We started by exploring the crucial role of LLM output configuration, digging into settings like token length, temperature, top K, top P.
Right, getting the settings right first.
And we journeyed through a whole spectrum of prompting techniques, didn't we? From the basic zero shot all the way to advanced stuff like React and even like automating prompt creation with APE.
Covered a lot of ground there.
And finally, we armed ourselves, and hopefully our listeners, with a comprehensive arsenal of best practices to help become, well, true masters of the prompt.
And as we've clearly seen, mastering this art and science of prompt engineering is rapidly becoming indispensable, wouldn't you say? It's really the key that unlocks the full potential of these incredibly powerful language models. Let's just leverage them effectively for just a vast and growing range of applications.
Yeah, absolutely. So for you, our listener, as you're processing all this, maybe take a moment. Think about a specific task or challenge you have right now where an LLM could help.
Right.
Why not make a conscious effort? Try out one of the techniques we discussed today, maybe few shot or chain of thought.
Or even just play with temperature settings.
Right. Or perhaps delve a little further into that intriguing idea of automated prompt engineering, see what happens.
Yeah.
Think of these LLMs not just as passive tools waiting for instructions, but maybe as potential collaborators in solving your problems. What exciting new possibilities might unfold when you approach them with a really thoughtful, skillfully crafted prompt?